Hello guys, welcome back to the channel for another Databricks video. This time the subject is going to be a bit more advanced than usual. We are going to talk about CDC or capture data change and CDF change data feed in Databricks using structure streaming and Delta Live tables. To give you a bit of a background here, if you are not familiar with CDC, capture data change is when we're going to propagate changes happening in the source downstream. Downstream in our case is the Lakehouse. We're going to do this automatically without a lot of code or implementing complex logic. When I started working with Databricks, the CDC and the CDF features didn't exist, which made things pretty difficult as you had to code everything from scratch. Not the best. But now by enabling CDF in Databricks, it's pretty easy to propagate changes like inserts, updates and deletes between the bronze, the silver and the gold layer. Even better, when you use Delta Live tables, you have this extra bonus of slowly changing dimensions of type 1 and type 2 to keep all the history you need for the business users. As I mentioned, the topic is advanced, but don't worry, I made everything as simple as possible for everyone to understand. Okay guys, remember when we talked about Delta Live tables in the previous video? We mentioned that one of the key benefits of using Delta Live tables is Delta Lake Change Data Feed, CDF, which makes it very easy to propagate changes from the source table to the target table and also keep the history of the data, which is very important for business users because sometimes business users want to compare old data with new data and they want to use historical data. So on the left we have the original table. As you can see, we have a primary key column and B is the column that we keep the data. Let's say we update A2 with a new value, we delete A3 and we insert a new record A4. Now when we enable CDF, by default we get a new table, and here is this new table generated by CDF, and we have the record that got updated, we have the pre-image, the record before it was updated, the version before the record was updated, and the new version after the update. So if you want to select, the original version before the change, you filter this change type column and you filter based on pre-image. If you want the version after the update, you just select the post image. It is that simple. You can also have you can see the deleted records here and the new records. So it's pretty efficient and effective to have this table, as we can use it as a base table when we use merge statements to propagate, and our changes to the gold layer, etc., etc. Moving on to our Databricks environment, I have already prepared a notebook that will demonstrate how to propagate changes through a Lakehouse using CDF. We are using structure streaming and Delta Live tables as well for this demo. So we have the bronze table. Here we store all the records as consumed. We get IoT data using structure streaming and save it on the bronze layer. Then we have the silver table. We deduplicate streaming data, and using a merge statement we write unique records to the silver layer. And then we have the gold table, which is the final destination, and we propagate updates and deletes to the gold layer using a merge statement again, but also using this CDF table you will see in a few minutes. How can we enable CDF? Well, we can do it by using this spark.conf.set, and you can enable change data feed. You set it to true, and this is how you can set it on a cluster level. That will ensure it is used on all newly created Delta tables in that scope, right? I have already created a schema called example, and let's create a bronze table if not exists. This is message ID, which is a string, device ID, which is an integer. This is, let's say, the key. In our case, in our demo, it's an integer, and temperature, RPM, angle, timestamp, right? And here, this is how you can enable change data feed on a table level. TBL properties delta.enable change data feed equals true, and this is how you enable change data feed on a table level. Now, if you describe this table, you will see in the properties, scroll down where it says table properties, delta enable change data feed equals to true, right? So this is how you do it. Otherwise, if you have already created a table, you can use this alter table table name, set tbl properties, table properties, delta.enable change data feed equals to true. However, as you can imagine, it starts from this point onwards. The next step is actually now to consume the data, the IoT data from the IoT hub. I have already set up this Raspberry Pi simulator, provided the connection string, and I have this IoT hub here on Azure. I hit the run button and it will start sending messages here. You can see message ID 1, device ID 4, temperature, humidity, etc., etc. And now it's time to consume the data using our structure streaming code here. We provide the payload schema and we use spark.readstream format Kafka because it's coming from IoT Hub, and we pass all these options here. .load, and we need to transform the body column. We add a new column, timestamp column here, and we select the columns that we want, right? And then using .writeStream format delta format, output mode append, and this is the checkpoint location and trigger. We use processing time 0 seconds. This is the best that you can get for processing real-time data. There is a continuous mode instead of processing time. However, you can, if you use continuous mode, you cannot save the data into a delta table. And I found that out when a subscriber told me, you know, I used continuous mode, but I couldn't save the data into a delta table, and I tried it myself. Yeah, it doesn't work. And then we researched on the documentation, and it says that, yeah, there is a limitation here. So the best you can get is processing time equals 0 seconds. And then we save it into a delta table in the example schema on the bronze layer. So let me run this code here. The stream has been initialized, and I think we have already triggered the Raspberry Pi. Yeah, it is sending messages. Now we should see this one working. Yeah, as you can see, we started receiving data, and let's select from the bronze layer. Let's see what we have. Yeah, we have 88 records. I think that's enough for our demo. Let me stop the Raspberry Pi. Let me also stop the stream. Let's get to the interesting part of this demo. So we have the data on the bronze layer, and here we can see all the data using this, let's say, table command. I don't know how it's called, table underscore changes, and here you provide the table name and the version that you want to see the data from, you know, from which version you want to see the data. Here it's 0, which is the first version. Remember, when we use delta format, every time that we make a change in the data, we generate a new version. And that's why we are able to restore the data by using a previous version. I cannot stress enough how important this is, because imagine if you drop a table. What are you going to do, right? You lost the data. Usually when in the database, you drop the table, okay, there is a way to get the data back. But when you truncate the data in a database, yeah, you lost the data. So what happens using delta format? You just restore the data from a previous version, which is pretty cool, which is amazing. Anyway, so here we can see all the data from the first version. Let me run this query and see what we get. Yep, as you can see, we have the data here, 93 records. We have all this data, device ID, temperature, etc., etc. And here we have underscore change underscore type column. And here you can see the operation is insert, because right now we generate IoT data and it is just append, right? So it's very simple. We just insert new data every time. Here you can see the version for this record and the commit timestamp. Perfect. Okay, so we have the data here, and we have enabled CDF on the bronze layer. Now it's not necessary to enable CDF on the bronze layer, because you just append the data. So, and the purpose of the bronze layer is to keep all the data, but for the sake of this video I just did it. But let's move on to the silver layer. Actually, let's see the described history of this bronze table. See what we get. As you can see, we have 22 versions, right? Come on. We have the operation column, which is streaming update. In our case, we have the operation parameters, output mode append, query ID. We have the notebook ID here, cluster ID with version, isolation level, operation metrics, etc., etc. So there is a lot of important information, although it doesn't look like it right now. Believe me, when it comes to real life, when you are at work, this describe history command can be proved very, very useful. Anyway, let's move to the silver layer. Let's create a table, same exactly schema, and that we have already enabled change data fit for on the cluster level, but we can do it here as well on the table level. And we are going to use a merge statement. So we are going to get the data from the bronze layer and place the data to the silver layer, but first we are going to drop the duplicates based on device ID. We can use with watermark timestamp 10 seconds, and then once we have deduplicated the data, we are going to use .writeStream and the for each batch method, right? And we are going to perform a merge statement based on device ID. When not matched, we insert all the data, the record, right? Output mode append, option checkpoint location, trigger processing time 0 seconds again. We have mentioned this part before, so let me run this and move the data, the deduplicated data, to the silver layer. The streaming query is running. I think it processed some data. Let's rerun this select statement for the silver layer. As you can see, we have 5 records and we have deduplicated the data based on device ID. So we have 5 records here, right? Let me stop the stream. And now if we describe extended the serial layer, we will be able to see that we have enabled change data fit here. It is in this location, right? And if we actually see what we have here in this location, what kind of files we have, we have the parquet files actually here and the delta log for the records that we have inserted on the bronze layer. Let's describe the history of the silver layer and see what we get. We have version 1 and version 0, version 1 and version 2. As you can see here, first was the query table because we created the table, the serial table, then we performed a merge and then another merge, and here the predicate conditions you can see, device ID, match predicates, etc., etc. You have all this information again. The operation metrics, again, very useful things. User metadata, engine info, etc., etc. Pretty cool, pretty cool. In general, the best practice is to enable CDF on the server layer. Let's see what the documentation says about this one. Read changes in batch queries. To read the changes from a particular start version to the latest version of the table, specify only the starting version or timestamp. So when you use batch queries, you have to select whatever you want from table underscore changes. You provide the table name, the start version in the end version, or you can use timestamps here, right? Or if you want to read everything from when the table was created, you use version 0 and that's it. Now if you use streaming queries, you have to use this one, dot option read change feed equals to true, and you have to provide the starting version or the starting timestamp. So it's a little bit different how you handle batch queries and how you handle streaming queries. Okay, let's go back to our Databricks notebook and run this command here. Select everything from table changes, and you provide here the table name, example.server layer, starting version 0, ending version 3. As we just witnessed, there are only 2 versions so far, so essentially we pick up all the data from all the versions. We can use a timestamp here, the commit timestamp column, or you can use you can select all the history using only the starting version. But remember, we are going to use structure streaming here. For structure streaming, this is the syntax. So spark.readStream format delta format, option read change data equals to true, starting version, let's say 2, table example silver table, and then we can select the data, only the updated data, so the latest data, by filtering the underscore change underscore type column is in update post image or insert, and select everything. We can do that, but let's run first a few queries. One is to insert data to the serial layer, just a random record with ID 12, right? And then let's update the record with device ID equals 1. Let's set the temperature to 54 and delete the record with device ID equals to 3. And then let's see what our server layer has now for data. Let's run this query again, this select query, actually everything from the start. Come on, SQL. So here we have the updated data. You can see the temperature has been updated for device ID 1. The change type now is post image for the updated data, pre-image for the original data, commit version is 4. Then we have this new record with device ID 12, which is an insert, commit version 3, and actually delete with version 5, because we deleted the record with device ID 3. This is, remember, this is what we saw on the slides. We have the change underscore type column, the commit version, commit timestamp, that you can see all this information here. And using this information, you can create your merge statement according to your needs, right? So if we run this one, Let's see what we get. Let's yeah, I'm displaying the query, so we should be able to see the updated data, the latest version of the data, because we are filtering based on the update post image and insert. So post image, this is the updated data, the updated record, and here we have insert, right, the new record. Okay, we got only 2 records because we are filtering based on the change type, right? And we are getting only the latest version from actually version 2. And here the original data, as you can see, that we didn't change it, they still have version 1. That's why we filtered out this data, because we are starting from version 2. Moving on, we can actually do the same, but instead this time filter for update pre-image starting from version 1. And let's see what we get here. I think we should get only 1 record because we updated only 1 record, right? Update pre-image, yeah, let's see. Yep, we only got 1 record because we updated only 1 record. This is the original data before it got updated. Let's cancel this and let's move to the deletion part. Here you can filter for the deletes. You can do that. We can run the cell and we will get only 1 record because we deleted only 1 record, if I remember correctly, with device ID 3. Give it a second. Yep, you can see here device ID 3, change type, delete. Let's move on to the gold layer. Usually on the gold layer we have, our star schemas, the aggregated data ready to query, ready for the business users to query the data. So let's say we want the minimum temperature, the average RPM, and the maximum angle. Here we have a merge statement. We have an inner query. I have created here an inner query that we select all the data from the serial layer since the beginning. You can specify the versions here, where the change type is update, post image, or insert. So we want only the records, the latest version of the records that were inserted and updated. And that's why I'm using row number here, partitioned by the device ID, ordered by the commit version descending, right? And then from this inner query, I use a select statement. I select the change type, device ID, and I aggregate I find the minimum for the temperature, the average for the RPM, the max for the angle. I filter for row number equals 1, and I group by device ID and change type. It's not necessary that you need to group by change type, but I will show you why I'm doing that. So I'm creating a temporary view, and let's select the data from this temporary view to see what we get. And we get this data insert for this device ID, post image for this device ID, minimum, average, maximum, okay, etc, etc. So we have this data, right? And this data needs to be merged to the gold layer. Let's create a gold layer table, device ID, minimum temperature, average RPM, and maximum angle. And here we are going to perform a merge statement again. We are using this temporary view and the device ID as a key here, and the target is the gold layer table apparently. When not matched and change type equals update post image, you can also add change type equals insert, or this and this, whatever you want. Then update, set the minimum temperature to the minimum temperature that we have in our view. And when not matched, then insert the whole record. So let me run the cell. Okay, and let's query this table here. And yes, we have the gold layer table with the aggregations, right? Device ID and the aggregations. Now, how can you propagate deletes? Exactly the same way. I recommend not using everything in one merge statement. You can do it like by using up here when not matched, then delete or something like that, but I think it's better if you do it separately. You select all the distinct device IDs from the table changes, from the serial layer, from the beginning, that have change type equals to delete. So with a with clause, and here we use a merge statement, and when matched, then delete. So we can propagate deletes this way, right? I think this is the best way to promote deletes. Remember that we erased the record with device ID equals to 3, right? So that's why one record got affected from this deletion, and we are going to propagate this deletion to the gold layer. As you can see here, we have device ID 3, we have all this data. So if we select now, if we run the same query, there is no device ID equals to 3 because we propagated the deletion. I think it's a very clear way to do things like that. You can do everything in one merge statement, but for me, I think it's more clear this way to separate the deletes from the main merge statement with the updates and the insertions. Okay, so up to this point we have propagated the changes that happened on the silver table to the gold layer, and we have used structure streaming to ingest the data to the bronze layer, move the data to the silver layer after deduplicating the data, and then using merge statements we move the data to the gold layer, the aggregated data. So how can you use delta live tables now? I will give you an example of how you can use delta live tables. So you have the serial layer, right? And let's create a new table called temp silver layer, selecting all the data, and then change those column names here. The change type, I have renamed it to operation type, commit version as c_version, commit timestamp as c_time. And you will see why I am doing that. And table changes, we actually select all the data from the beginning. Let me run this command. And let me select from this table. Okay, so I run this query, we can see all the data from the beginning, all the versions, etc, etc. Now let's see what the documentation says about CDF and delta live tables. Simplify change data capture with the apply changes API in delta live tables. Delta live tables simplifies change data capture with the apply changes API. Previously, the merge into statement was commonly used for processing CDC records on Databricks. However, with apply changes, we can ensure that in delta live tables ensures correct processing of CDC records and removes the need to develop complex logic. The apply changes API is supported in the delta live tables SQL and Python interfaces, including support for updating tables with slowly changing dimension type 1 and type 2. which is extremely important and an added bonus. Use especially the second one, type 2, to retain history of records, either on all updates or on updates to a specified set of columns. How is CDC implemented with Delta Live tables? You must specify a column in the source data on which to sequence records, which Delta Live tables interprets as a monotonically increasing representation of the proper ordering of the source data. For slowly changing dimension type 2 changes, Delta Live tables propagates the appropriate sequencing values to _start at and _end at columns of the target table. And also one more thing we should know about that is when you declare the target table in the Hive metastores, two data structures are created. A view using the name assigned to the target table, apparently, and an internal backing table used by Delta Live changes to manage CDC processing. This table is named by prepending _apply _changes _storage to the target table name. However, it says you should not query the table for production use, this _apply changes storage. And then if you scroll down, if you scroll further down, you will see an example here. And you can see the syntax for slowly changing dimension type 1 and type 2. This is the one we are looking for. This is the syntax, and that would be the target table with those two columns, start at, end at. So we also have slowly changing dimension type 2 columns here, which is an added bonus and a very good one, I have to say. So this is the syntax, the Python syntax and the SQL syntax. And let me go into my workspace. First, let's see the Python syntax. Here we have to import the Delta Live table library here, and then using the decorator, of course, we need to use spark.readstream format delta and specify the table, silver table, because we need to, in order to apply Delta Live tables as a source, you need to have a streaming table. So here that's why we use .readstream, that's why it's important. And then we can create a streaming table called target DLT Python. And here in the apply changes method, we specify the target table name, the source, the temporary table that we created before, and here that we read it as a streaming table, the keys, device ID, sequence by ctime, right, operation type delete, apply as deletes, except column list. You can remove some columns and stored as slowly changing dimension type 2, right? I think we are good to go. Sequence by ctime, operation time, yeah. So here I need to run a Delta Live table pipeline. Let's create a Delta Live table pipeline here. DLT Python advanced triggered users, the Python version now, example, autoscaling now 0 workers, create, and let's run this one. And essentially we expect our target table to have two added columns with the start and the end. Excellent, our Delta Live table pipeline has already run. As you can see, we stream the data from the temporary serial table to the target table here. The source code is this one, and this is the target table. And we can do the same, so for our SQL script here, same thing, target table. Of course we changed the target table name, and we apply changes into the target table from stream, the temporary singular table that we created, keys, device ID, apply as delete when operation type equals delete, sequence by c_time, columns, everything except RPM, stored as slowly changing dimension type 2, which is fine. Now I will tell you why I renamed the columns here, because apply changes API is using the same columns internally for all the things it has been doing behind the scenes. So if you don't rename those columns here, it's going to give you an error, but you just have to rename the columns. It's pretty simple. Let's go back to our Delta Live tables. Let me delete this pipeline. Let's create a new one pointing DLT SQL to the SQL script. Paths, let's provide our SQL path, this one, right? Target schema, example, 0 workers, because our shoestring budget that we don't actually have. Let's create and let's hit the start button. It will take a couple of minutes. Let's wait. As you can see, the Delta Live table pipeline with SQL run fine, and we have the data in the target table here. It's pretty cool. If you think about it, you can do a lot of things using structured streaming or Delta Live tables. Both are pretty cool tools actually. Now if you go into your Hive Metastore, you will see all those tables that we created. This is the target Delta Live table. It has all those columns. Remember that we have new columns __ start at and _end at, and here this is null because this record is still valid. This one has it's not valid anymore. And this is the target table using the Delta Live table SQL syntax, exactly the same records, and we have this slowly changing dimension type 2 columns, which is incredible, right? And also, as you can see, we have those two tables, __ apply changes storage, and then the table name that the documentation says that we shouldn't trust because they keep changing, they keep developing those tables. So just use the target tables. This is it for today, guys. I hope you enjoyed the video. I certainly did. I wanted to make a video about CDC and CDF in Databricks, as it is a very important topic that gave me plenty of headaches in the past, to be honest. Fortunately, Databricks is keep evolving, and those new features are extremely useful and efficient. This is what I like in Databricks. It keeps getting evolving and it keeps getting better. Hope you enjoyed the video. Please click the like button, leave a comment and subscribe to the channel, and I will see you in the next one. Thank you.